So here we have some basic examples of problems where we have to find limits of functions. The first one is a polynomial function, limit of 3x squared minus 2x plus 1, as x approaches -1. The important thing to know here is that a polynomial function has no breaks, no asymptotes. It's just like a smooth curve going up and down, eventually possibly going up and going down at either end. But here what we have is a quadratic polynomial which looks like a parabola. Either way, a polynomial function is continuous everywhere, so therefore we can find the limit by substitution. So when we substitute, we get 6, and that's the limit of the polynomial as x approaches -1. Now we look at the next problem, and that is limit of x times 2x squared plus x plus 1. So here, this again is a polynomial. We have a quadratic polynomial times a linear polynomial, which is equal to a cubic polynomial, because 2x squared times x is x cubed. So it's 2x cubed. So we have a cubic polynomial, but if it's a polynomial, we know it's continuous. All we have to do is plug in the limit and we get our answer. And that is equal to 0. Now let's look at problem 6, which is the limit of sine 3t as t approaches pi over 9. The sine function is continuous. It's a periodic function. It looks like a wave. And we try substitution first. So when we substitute, we get 3 times, and we plug in pi over 9. We can cancel the 3 with the 9. 3 goes 3 times into 9. And sine of pi over 3 is radical 3 over 2. So that is the value. So you can get the sine of pi over 3, use your tables or just memorize. These are standard angles. Pi, pi over 2, 0, pi over 3, pi over 4, pi over 6 are all standard angles, and you need to know the basic trigonometric values of these standard angles. Now let's look at problem 8. It's the limit of tan, again trigonometric, of x minus pi over 2 over 2. So now x approaches pi over 2, so we plug in x equals pi over 2 to get tan of 0 over 2. Tan of 0, if you don't remember what it is, it's sine 0 over cosine 0. Sine 0 is 0, cosine 0 is 1, so 0 over 1 equals 0. Limit of, so this we are looking at problem number 10, limit of the function e to the x plus 1 over 2x plus 3 is equal to, now just plug in x equals 0. So e to the 0 plus 1 divided by 2 times 0, remember x is 0, plus 3, that's equal to e to the 0, which is 1. Any base that is non-zero to the 0 power is 1. So e to the 0 is 1. 1 plus 1 divided by 3 is 2 over 3. So the answer is 2 over 3. Notice that all we are doing is substituting the limit. And the rest can be done with a calculator or just some basic knowledge of pre-calc. Now the last one we'll look at is problem number 12. It's a natural log function ln of t cubed as t approaches e. E is an irrational number, so we plug it in. That's the first thing we do. Ln of e cubed. So instead of t we have e. So that's equal to ln of e cubed. So that is ln is log to the base e. So log to the base e of e cubed. Remember the exponent by the rules of logs. We move it here, make it a multiple. We're left with log e to the base e. Log of any number, let's say a to the same base, is always equal to 1. So 3 times 1 is 3. So we just need to know some basic facts about the log function. Remember, the log of a number to the same base equals 1. We also have to remember that log of 1 equals 0. We also need to remember that if we have log of, for example, 5 to the negative 3 to the base 5, if this base is equal to this base, then the log of the number is the exponent negative 3. So again, just one more example, log of 10 to the 15, and if the base is 10, then log of the number is 15. If these two match, then the log of the number is the exponent.